In this video, we're going to be covering an overview of the BobCAM for RHINO user interface. So the user interface is really just RHINO. So you have to be aware and kind of know how to use RHINO. We don't really go into how to use RHINO. You can import parts, but really we're just going to go through the BobCAM portion of this job. So there's 4 tabs that you get when you load up BobCAM, but you also have a toolbar. So we'll start with this toolbar. The toolbar right here, the first thing we see is our settings. So when we open up the settings, this is where we're going to go to find all of our document and current document default settings. So it's our data folder, where we store our CAM features, whether or not we have the flyouts for the CAM tree enabled, meaning we can go change things like feeds and speeds right on the fly through the CAM tree without having to open the feature. Right here we have our help improve BobCAD by sending the usage statistics. This is something I talked about in the registration video. What we're trying to do is find out what features are the most often used and what features aren't, so we can put our focus towards the right things. This is all anonymous. You do not have to worry about us knowing who you are or where this information is even coming from. It just shows up and tells us what kind of features are being used. If you don't want to use it, just uncheck that button right there. Now right here for user interface, we could just choose a theme. So we have just different themes that we could choose. So here's Office Black. I could say apply, and it's just going to change the way that BobCAM for RHINO is going to look. Now right here we have our document defaults and our current document. Now the difference between these two is the document defaults are going to be our overall default settings of the system. And then the current document is just for the document that you currently have opened. So right here for my document default, these are things like the system tolerance, your chain select tolerance, your spun profile tolerances, your 2-axis, 3-axis, and lathe tolerances. And you'll notice I only have this going out to 3 places, so I'm just going to hit OK. I'm going to go up to Tools and then Options real quick. I'm going to go up to my Unit section, and I'm just going to choose this to go out to 4 places and then hit OK. So now when I go back into those settings there, we'll see I have all these numbers showing up properly because some of these numbers are very small. So we set up our tolerances for everything. We set up our workpiece and fixture tolerances for specifically simulation. And then right here we have our default machining order. So we have our milling job, we have our probing, we have our turning job, our mill turn job, and our wire EDM job. And this is just asking, how do we organize this? So we have this option called individual feature, meaning whatever order you have your CAM tree output in, that's the default order that's going to show up inside of BobCAM. Now this is primarily going to be used when you have a tool changer. But if you don't have a tool changer, you might want to spend more time using one tool before trying to switch tools. So that's where you'd use either individual tool per machine setup or individual tool. And most of these are going to have the same kind of information other than probing and wire. So probing is sort between probing operations. You can probe your operation, but it must follow a CAM tree sequence. So you're going to put it after a feature. You're going to probe before a feature, or no probe operation influence, meaning it doesn't influence the order at all. Again, that would be the one, if you just had it set up in your CAM tree in a specific order, that's the one you'd want to use. And then for wire EDM, you have a choice of doing either individual feature, so that means it's going to follow the order of the CAM tree. You could do operation type, so you could say I want to do all my rough passes, then come back and do all my skim passes. Or you could sort it by your pass sequencing. Down here for the colors, this is just what colors are used when we have geometry in the screen that we add to it. So the two things we're really going to do is highlighting geometry and showing toolpath. So what color shows up when we highlight our geometry. So when I'm all done, I can go ahead and hit OK, and that's going to be my kind of current settings for the setup for how BobCAM is going to work. Next to that, we have an option to start a new job. We have the ability to start a new job from a template. Right here, we have our current settings. Now, current settings is where we go to select our machine, our post, and all that information. So right here, we have our default machine. It's always going to come up with this BC3X mill, but you can go through and try and find your machine, or you may need to add your machine to the system. And you can actually add a new machine and create a new machine. Otherwise, most of the time when you get a post processor, it does come with a machine that's already kind of built and ready to go. Right down here, we define the maximum number of tools. Right here, we add in and tell BobCAM what our rapid feed rate is. This isn't something that we define through BobCAD. This is a setting that's on your machine. So this is just asking what's the rapid feed rate. Right here, we have our maximum spindle speed. And then right down here, we have our maximum cutting feed rate. So you just want to set this up so they all match your machine specifically. And then over here on the left, we have our machine definition. Now, the machine definition is how the machine in BobCAD, so this BC3X mill that I'm using, is set up and how it's built kind of virtually. How does X, Y, and Z interact with each other? It's also where we can go to define the size of the table. So in this case, my Y-axis is 24 inches of travel. I have a -12 and a +12. And the reason I have these numbers here is because the way we define a machine inside of BobCAM is based on the exact center of the table. So from the center of the table, I can go -12 inches and +12 inches. If we look at X, we have a -28 and a +28. And if we look at Z, we have 0, meaning that the spindle without a tool in it can touch the table. And it raises to 24 inches tall. So you're going to want to make sure you set that up just so you don't get over travel errors inside of your simulation. Now, I wouldn't mess with this too much. If you are going to make changes, that's the only changes I would recommend making. If you're going to change anything else or you think something else has to change, get in touch with tech support and talk to them, see if they have a better way to make those changes. Over here on the left, we then have our posting tab. Now, the posting tab is our post processor. So we'll see I have my post processor for my BC3X mill. And you can use the BC3X mill. It's a generic 3-axis machine. The most important part is that you have the correct post processor selected. And you can find your post processors by going to your C drive. And then there's a folder in here called BobCAD-CAM data. And then for me, I'm going to go down to the BobCAM for RHINO V1. And then I could go to my posts folder. And then I'll choose mill, lathe, mill turn, or wire EDM, whichever job I'm running. And then I can choose which post processor is going to get pulled up for this. So I can actually tell BobCAM which post that I want it to output with every time I output my code. So I'm going to leave it with the BC3X mill, just a generic little 3-axis post there. Right down here, we have our NC file path. This is the location where we default to saving the NC files that you produce through BobCAM for RHINO. And then right down here is the NC file extension. This is the extension that your specific machine is going to need to read the files that are output from BobCAM. Right here we have our program number. So it's just the number we add to the beginning of the code when we post it out. Right here is our absolute or incremental settings. And most of the time with these posts, the post processor itself is going to define whether it's absolute or incremental. So we're going to leave it on the post setting. Right here's our sequence numbers. If you want your line numbers in the beginning of your lines of your code, you could have an N1, N2, N3, and so on. You'd say start at 1 and increment by 1. If you wanted to do count by tens, you could say start at 10 and increment by 10, and that's going to give you an N10, N20, N30, and that's going to give you the spaces in between. I could also come in and set zeros in both of these boxes. And then in this version, we will no longer have line numbers outputting. Just remember, if you move this to another computer, you will have to make this same settings change or call tech support and ask them to edit your post processor and turn off these start numbers and the increment numbers. So you'll get rid of your line numbers completely. Right here, we have an option to output subprograms. Your post has to be set up for subprograms to even output close. So you're going to want to make sure to output subprograms. But again, you'll want to make sure to work with our posting department and get it all squared away first. Right here is use transform planes and output arcs into 4-axis NC programs. That's for 4 and 5-axis. It's not something we need to worry about unless you get into that. And if you get into that, we'll do some special training and show you how to use these types of features. Now, if you have a machine that has an issue called dogleg rapiding, essentially, instead of doing a straight line for a rapid, it curves the line. So X or Y ends up essentially getting to its position before the other axes. So instead of doing a straight line, you end up hitting, say, your Y axis and then traveling down your X. So you end up with a bigger kind of arc move. And depending on your fixturing for your part, there's very good potential for collisions there. So this is an option that gets rid of that issue. So you go in and you say machine does dogleg rapid, and what we're going to do is we're going to take out all the G00s from your program and replace them with G01 moves. But on all those GO1 moves, you're going to have a feed rate that's going to be close to a rapid feed rate. So maybe you'll go up to 200, 300 inches a minute, and that'll count as your rapid move, but it'll make sure that it travels in a straight line from position to position. And then right down here, we have output automatic comments. Now, automatic comments are all built in through your post processor. They essentially say things like next cut, next tool when there's a tool change happening, or next cut, same tool if you're using the same tool but moving on to another tool path. Those are your automatic comments. If you don't want those to open up, you just uncheck output automatic comment. Right here, we then have our multi-axis posting, which you really shouldn't have to mess with anything on this unless you're getting into multi-axis. And even then, the machine's usually going to build with most of these settings put in. For 3-axis and what we're doing in this set of videos, the only thing we really want to make sure of is on standard, under move list coordinates here, it says machine compensation in Z only. When we're done with that, we can hit OK, and that's our current settings. Next to that, we have our cutting conditions. These are drilling parameters specifically. So I'm not going to go through all the features in here, but the one that you may notice, or the one you might not understand where it's coming from, is like right here, the drill, we have our length through cut. So length through cut right now is set to 50 thousandths. And what that means is when we drill a hole and we tell BobCAM that is a through hole, we're going to automatically add 50 thousandths onto the depth of cut. So you could go in here and change these settings. Most of them are for different situations for reams and bores and chamfers, but you could set up your defaults so that every time you go into your features and run something like this, you don't have to go in and change those settings. So I'll go ahead and hit OK. Next to that, we have our DMS defaults. These are our dynamic machining strategy defaults. And this is primarily used for setting up specific features. So if you go in and you do a drilled hole, so I go to the mill hole operations or templates here, and we have our center drill, and then right down here we have a hole. Now when I choose hole inside of a feature, it's going to choose a center drill and a drill. But if I never run a center drill, what I can do is click on the center drill here and get rid of it. So now every time I do just a hole and I choose that option, it's just going to load in a drill and not a center drill and a drill, just the drill. Now, if I want to add more features to this, or I want to customize them like we can do more with the 3-axis templates, over here's our available operations. So I could go ahead and move that over, and then I could actually move it up or down. So I'm just going to move it down so I have my center drill and my drill back in there. So every time I choose drilling, I will have a center drill and I will have a drill. The benefit of this is you could set it up for the way that you normally run, but just remember, if you accidentally take out your center drill, you can add it back in on the fly. So if most of the time you just drill, then it might be worth it to come get rid of the center drill out of here. But in the jobs where you do want to do a center drill and a drill, you can add that center drill back in. Next to that, we have our tool library, which we're going to look at in the next video. Next to that, we have our tool holder library, which will be part of the same tool library video there. Right here's our adapter library. So if you're getting into mill turn, you'll need to build adapters and make sure you have the right adapters for your turret. Right here, we have our thread library. So this is going to be all of our different thread types inside of BobCAD. So we have our national pipe, we have our American, coarse and fine, your British up top, just all the different types of threads that you can create or use. And they all have their own settings. So if I go into something like a quarter 20 here, we'll see that when we choose a quarter 20, it has all of the information defined about the thread mill. And then right here, we actually have our hole sizes. So if it's a cutting tap, we're going to set it up as a 201 drill. If it's a rolling tap, we'll use a 227. So this is actually going in and picking the drill size or defining the drill size that's needed when we do these threads. So I'll hit OK, close that out. So next to threading, we have our material library, which we're going to look at in a couple videos. Right here's a shortcut to launch the simulation, close the simulation, and then launch the NC editor. Now on the 4 tabs that we have here, the first one is our data entry. And this is really where we just go to enter in information. When we go to pick geometry, this is the tab that's going to highlight for us. So we don't really have to mess with this too much. There's nothing really on here. Right here's our CAM tree. And this is where we could start a new job. We could start a job from a template. We can go right here and show or hide the stock, just kind of hide things. We can blank or unblank our tool paths. We can launch our simulation. We can post our code, or we can post and save our code. Now, what I want to do real quick is I'm just going to start a new job just by right-clicking on where it says CAM defaults. And most of the same options that we find right here are actually listed here. Again, you're going to do that by right-clicking on CAM defaults. And this is where we could also get into the cutting conditions and the current settings, those DMS defaults, pretty much all those buttons we have at the top. There's another way to get into them here. So I'm going to say new job. I'll tell it that I'm milling, and I'm just going to go ahead and hit OK. And this is going to populate the rest of the CAM tree with a milling job. So if I right-click on milling job, this is where we start getting a lot more options. So we can go into our current settings. We could set up our machining order. We can post and save as. We could generate setup sheets, launch our simulation, see toolpath statistics, update geometry, basically reselect any geometry in case the part changes. We have our compute all toolpath. Post yes, no turns toolpaths on and off so they do not simulate and they do not post. Blank unblank is visually just going to hide the toolpaths. Then we have our cutting conditions. We have our ability to save as a job template or job defaults. We have another setup. So right now I'm using just machine setup 1. This would allow me to set up another machine setup. We can delete the milling job and we can expand and collapse items, or we can rename it. Now, right below that, we have our template that was loaded up, but I'm just using the system default. Below that, we have our milling machine as well as our post processor. Right here, we have our milling tools, which gives us options to go into the tool library or into the tool crib. We could look at our tool holders and we could verify our tool assignment. Right here's our workpiece. Basically, the workpiece is a solid model that you'll have open inside of your RHINO that represents the final finished part. And this is a way to basically add that in so we have a workpiece that we could view when we're simulating. So we could see that final finished part compared to our machined part that we run as we create all these tool paths. Right here, if we expand stock, we have our stock as well as the material that's currently chosen. Right down here, we have our machine setup. And then right below that, we have our fixture. And then right here with the machine setup, this is where we're going to go to add all of our tool paths in. This is where we'll find, say, for milling, we have our drilling options, tapping options, counterbore and counterbore tap. We also have facing, 2-axis, 3-axis, our 4-axis rotary, our mill multi-axis, our mill threading, our 3-axis wireframe, like a 3D engraving toolpath, and then our mill V-carve. Under additional functions is where we're going to find update geometry, compute all toolpath, add new groups and indexes if you're doing 4th axis, same with the wrapping groups, as well as toolpath patterns. We have another setup that we can create. We have delete all features for when you really mess up, and collapse and expand items. Now you can load and save toolpaths. So you can actually save a toolpath from a previous job and then load it back in later on. You could even copy and paste toolpaths. So if you've made a pocket and you need another pocket on the same part, maybe because it's got a different depth to that pocket, you can actually copy your first, paste it, and then use that same feature to go and cut your second pocket. You just have to go in and update your depth of cut and update your geometry. Post yes, no is how we turn toolpaths on and off so they do not post, they do not simulate. And then blank on blank toolpath is visually just going to hide the toolpath. And then rename is going to let us rename that machine setup 1 to whatever we want. The next tab is our BobArt tab. This is where we can go into load images, either vector files like PDFs or AI files, or just load in JPEGs or PNG files and bring them in. So we could either basically extract the edges from the image or vectorize the image, or we can actually emboss and make a 3D relief, kind of like a lithophane for our BobArt images. Now, when we finish doing all of our tool pathing and it's time to post our code, that's going to show up on the posting tab. So you want to make sure you have the right post processor selected. Again, that's under the machine here. You'll make sure you have the right post processor selected. You'll say post, and the code's going to show up right here. Now, after you post the code, you could then right-click and either save it, or the other part of the software, and this did install when you installed your BobCAM for RHINO, is the NC editor. This is where we actually send the code to either backplot it if you have the NC Editor Pro, or you could just view the code, make modifications to it, and actually send it out to your machine. And most of these things we're going to cover during this short set of videos here. And if you want more detail, get in touch with tech support, get in touch with training, and get some training on all the rest of these features that you'd want to learn about. And that concludes the video on the user interface overview for BobCAM for RHINO.